When it comes to solving limits at infinity, I know what you're probably used to. You're probably seeing limits like this, where it's just like some polynomial over some polynomial, and you just compare the exponents. Or maybe you've seen limits like this, where it's like it's kind of a polynomial on top, and it's a polynomial on bottom, and you got to do a little bit of thinking. But what about limits like these, where if I were to try to compare the exponents, I can't really do that for real because the exponent isn't a number. What do you do? In cases like these, all you basically have to do is just compare the growth rates between the numerator and the denominator. And you have to make sure to pay attention to whether x is approaching positive infinity or negative infinity. And so essentially what you're doing is just looking at what's happening to the numerator and the denominator as x gets really, really big or really, really small. Our numerator is just e to the x. And if you know what e to the x looks like, y'all know e to the x just kind of starts off flat and then it just kind of, and then on bottom you have x to the 6, which is, it's kind of like an x to the squared, but just like, it just grows faster than x squared. So really what we're looking at is between e to the x, an exponential, and x to the 6, which one grows faster. You just kind of have to know and think about what the power of exponentiation as opposed to just raising a number to the 6th power. But to visualize this, let's look at this on a graph. All right, so as you can see, I got both e to the x, which is in red, and x to the 6th, which is in blue. And I'm just looking to see which one gets bigger faster. And what I like to do is think of the x-axis as kind of like a timeline. Think about like 0 seconds, 2 seconds, etc. It looks like at first e to the x like is up, and then x to the 6, it kind of grows faster, or like it beats e to the x. So it looks like x to the 6 grows faster, but what you have to remember is it's as x approaches infinity, not just like the general beginning area. So this is that same graph but just zoomed in a lot. And if you look at the red graph right here, which is e to the x, you can see that eventually it does start beating x to the 6. So e to the x does grow faster than x to the 6, which hopefully you can imagine that being true. So just think about it as like a really big exponent is bigger than 6, which is the denominator's exponent. And if we want to look at the overall graph, you can see it does start out going down. So like I said, it seems as though x to the 6 is winning, making the bottom bigger. But remember, as x approaches infinity, you can see my graph just starts launching up. So as x continues to get bigger and bigger, this overall value is going to just keep getting bigger and bigger as well. So our answer is just infinity. And if you want, try these. Let me know what y'all get in the comments.